8.1 is distribution of the sample mean.
It's
Hmm?
so how would because I tried to Google a calculator for that this morning.
Distribution of the sample mean?
Yeah, would I just put in sampling distribution calculator or
Now this though, I don't. You really wouldn't need one,
mm,
because it's leaning on your z-scores and the z-score chart.
oh Lord, never mind.
Yeah.
Go on with the study, sir.
All right. All right. So our first statement: the sampling distribution of a statistic is a probability distribution of all possible values of a statistic computed from a sample size n. All right, so we're just setting some groundwork.
Did you know you could speak that in and it'll type it out for you?
Oh, I can.
Uh-huh. If that's
As a matter of fact, you just made me think about something.
what was that?
Hold on one second. Just hold tight, hold tight. You just made me think about something.
Yep, because Word has that dictate where you could just dictate that in.
Mm-hmm. This one, sample distribution, proportion, sample mean. All right. Give me one second, y'all. I got these written up already. All right. That should be good. Can y'all see that okay? The sampling distribution of a statistic is the probability distribution for all possible values of a statistic computed from a sample size n. Can y'all see that okay?
Can you zoom it in a little more?
Let's see if I can. If not, I may have to write it out.
No, we can see it.
Y'all don't want to wait for my handwriting?
No, your handwriting's beautiful. Just
All right, so let's look at this. We already did that first one. So the second one, the sampling distribution of the mean, of the sample mean, X bar, is the probability distribution of all possible, right here, all possible values of the random variable X bar computed from a sample size N from population with mean mu and standard deviation sigma. So all this stuff is gonna make sense once we put numbers to it. But right now I gotta give you that foundation.
That's what you say. It's a z-score. It does not make sense to me.
Next one says suppose, right here, suppose that a simple random sample size n is drawn from a population with mean mu and standard deviation sigma. Then the sampling distribution of X bar has the mean of this characteristic, and your standard deviation we will find by using this relationship, sigma over square root of your sample size. All right. And here this statement, the standard deviation of the sampling distribution of X bar, that sigma sub X bar is called your standard error of the mean. So basically this right here is called the standard error of your mean. And it says if a random variable X is normally distributed, the sampling distribution of the sampling mean X bar is normally distributed. And this is the part that Ms. Buffalo don't want to see. If it's normally distributed, that means that we can use the z-scores. Before I forget again, I'm not being clear.
Don't nobody want to do z-scores.
All right, saw your message, Ms. Buffalo. We're good to go. All right, so I'll give you guys a chance to finish writing that before we go to the next page. Sorry about that. All right, so are we good to go? Don't want to move if you everybody's
I'm here.
everybody's still, so I can go to the next page.
Just waiting on this z-score crap.
So I'm gonna stop and have to go out of it, go to the next page. All right, where's my Zoom? All right, so let's look at the first example and use what we just finished mentioning. It says the IQ X, we're using X as our IQ. The IQ of humans is approximately normally distributed. So once again, that normal distribution lets us know that we can use the z-score relationship with mean 100, standard deviation 15, compute the probability that the simple random sample size of n equal to 10 results in a sample mean greater than 110. All right, so we're starting here with the given information. And I'll wait a second. I'll let you guys write that first before we start with this discussion.
Is the Z-score chart the same as the one on A11 and 12?
Yep.
That chart is wrong or something.
You said it's wrong?
It gotta be.
Well, it's been right all the way up to this
It hasn't
semester.
worked for me at all, any.
So we'll see what's going on with your problems. But it's been right all the way up to this semester, I will say.
I sat there and watched you do it.
Mm-hmm.
I had the office session. I went right to my chart because I got like 900 of them printed out.
Mm-hmm.
And I did the same steps and still couldn't come up with the right numbers.
All right, we'll see what's going on.
Sir, is that 15 divided by 10 squared?
The square root of 10. Mm-hmm. So,
Square root.
Yep. So let's go ahead and get into it. So you always start off listing what you know about the problem. So they give us our mean, which is 100, standard deviation is 15. The sample size is 10, that's lowercase n. They don't have to write n equal to 10. If they call it the sample size, then you're supposed to know that is lowercase n. And then the data value that we're doing the comparison to is 110, and that is the mean, this mean of the sample. All right. So according to that, one of those last statements that we did in our first sheet, the mean of your sampling distribution is going to be equal to the mean of your population. So that's why you have that equal to 100. Then the standard deviation of your sampling distribution is equal to the standard deviation of the population divided by the square root of your sample size. So that's where we got the 15 over the square root of 10. And so that's 4.743. So before we go any further, is everybody okay with this part? We got it, what we did.
Yes.
All right, sounds good. So notice the next part or the next step is to find your z-score. And the way we do it is with this relationship right here. So that takes us to 110 minus 100 divided by 4.743. And that gives us 211, 2.11. All right. So now we go to the z-score chart, which is the chart that Ms. Buffalo does not like. And once you go to the chart, that gives us 0.926.
Now, how'd you find that?
Huh?
Find that you went to the positive 2 on the chart, right?
2.1, you'll go 2.1 over
And
here.
then 1, 0, 1, right?
0.01 up here, right? And they should meet, right? You know,
Let me tell you, don't work for me.
0.9826. And all right.
You got a different chart.
I got a different chart.
Got
All right,
to.
hold on, y'all. I gotta pull up the chart.
No, don't pull it up. Keep
You
on.
want to pull up the chart?
I have 100 of them printed out. Just keep going. I don't want to hold everybody else.
Now, well, just in case somebody else needs to see it, it's not a big deal.
I do.
See, there you go. That's what class is for. So I don't have no problem with that. But so now all z-score charts aren't created equal. Now some charts are harder to read than others. I'm just going off of the chart that the book gives you. Now there are different ways that this is set up. They all should give you the same value. No matter what you do, it's just that some of them are different processes in order to do it. Some of you have to add 0.5 to it and different things like that. The one that you have, you would go to
Came
the
from the
positive.
book.
Say again?
I'm using the one from the book.
Yeah, so this is the one out of the book. So you go to positive 2.1,
Right.
and then O1
0
up here, and there we go. And that'll be 0.9826. All right.
Oh.
Now I'm not saying that's the answer yet. We got to evaluate, but that's what you should be pulling from the chart.
It worked for me that time for some reason. Okay.
All right, all right. So let's go back to our notes. So now we want greater than. Remember, the chart always gives you less than. So if I want to know what greater than will be, I will subtract the chart value from 1. And so my answer is 0.0174. So don't forget, the chart that the book gives you will always give you less than.
You subtracted 1 from 0.9826?
Yes.
Okay.
Yep. So if you want greater than, you always have to subtract that value, the chart value, from 1. And then so the probability of obtaining sample mean IQ greater than 110 from the population whose mean is 100. Got all those numbers from the problem, but our answer is 0.0174. All right. Questions on that one before we move to the next thing in this section?
Yeah, can you not put Z scores on the final exam?
It's going to be kind of hard to not put it up there at all, at
Okay,
all.
you only put 1 Z score problem?
Just put 1.
Jesus. And them darn Y intercepts.
Everybody had a kryptonite. I know you Superwoman, but everybody had a kryptonite, right?
You better not. I take quick math.
It's math.
It's yours?
I failed 4 classes
Oh, man.
of math. I paid, and I know I'm going to fail this one. So
Oh, man, nah. Nah, we're not going to let that happen, sir.
my dad said he'll give me $100 if I pass this.
Oh, we gotta
I'll give you $100 in advance.
No, we got to get that money for you, sir.
Thank you.
Yeah. So that's 3. Trying to make sure I got the right sheet.
Some tag team tutoring.
Hey, you nothing wrong with that. All
I just paid $700 for my daughter's wedding dress, and I got like $700 more to pay.
Oh, wow.
You
So
better pay math class.
Yeah. I'm sorry. Love you guys.
Fine. You're fine, sir. All right, so here's our next sheet, the central limit theorem. And let me make sure I'm matching it up with our stuff in the notes. Standard error, 15, yep, that's it. Central limit theorem, yep, we good to go. Regardless of the shape of the underlying population, the sample distribution of X bar becomes approximately normal as the sample size N increases. Remember, approximately normal means I can use the Z-score relationship. So we want to increase our sample size or have a large enough sample size so that we can use the approximately normal distribution. So if the distribution of the population is unknown or not normal, then the distribution of the sample mean is approximately normal provided that the sample size is greater than or equal to 30. So we're going to need our sample size to be greater than or equal to 30 if our population size is not normal. Remember, we're talking about normal distribution has the bell-shaped curve. So that's what we're talking about there. We need an approximately normal distribution. All right. So the next example, the mean weight gain during pregnancy is 30 pounds with a standard deviation of 12.9 pounds. Weight gain during pregnancy is skewed right. So if it's skewed right, erase this one.
If it's skewed right, we look to the right on the Z-score chart.
No, that's just about your distribution. If it's skewed right, that means that the tail of your data is to the right and the bulk of your data is to the left. So that's all that means. They're just saying that it's not normally distributed. So an obstetrician obtains a random sample of 35 low-income patients and determines their mean weight gain during pregnancy was 36.2 pounds. Does this result suggest anything unusual? So now, even though our data is skewed right, that's not normal distribution. But remember, when we go back to what we need in order to assume approximately that is normally distributed, is something, sample size is greater than 30. And we have a sample size that's 35, greater than or equal to 30, and our sample size is 35. So since it's 35, according to your central limit theorem, that means we can use your approximate, your normal distribution. And that means we can use our z-scores. Gives us the ability to use our z-scores. All right, give you guys a chance to write this out before I go to the next page. All right. Are we good to go? Good to go. All right, so let's go to the next page. And of course, it didn't pop up. There we go. All right, so here we go. So we're gonna write down our givens first. Notice right here is our given. We have our mean was 30. Standard deviation is 12.9. Sample size is 35. And the mean of our sample is 36.2. All right, so that means our mean of our sampling distribution is 30. And then the standard deviation of our sampling distribution will be at 12.9 divided by the square root of 35. And that's 2.180498. Excuse me. So then once you do that, define your z-score. And so that's going to be 36.2 minus 30 divided by 2.180498. And that value, you know, how far you go out as far as your decimals are concerned is up to you. The further you go out, the more accurate you are, of course. I just did that for accuracy. But that'll give me 2.84 as a z-score. Go to your chart, you should get 0.9977. And once again, that's less than. Now, so look at my next statement. Since we want to know how unusual this is, then we want to know the chance of it being greater than. What's the chance of us getting something greater than this value? So if I want to know greater than, I subtract that from 1, which gives me 0.0023. So
I'm sorry.
No, you're fine.
So you just take 1 minus the z-score?
The chart value that the z-score gave. So your z-score is 2.84.
Okay.
Now, when I go to the chart, I get this value, which is 9977. That's the value I'm going to subtract from 1.
Okay.
Yeah.
Thank you.
Mhm. All right, and so last statement, this will be unusual for us because the probability of getting something greater than that is going to be less than 5%, which is at 0.05. Remember we talked about something being usual versus unusual. Is you know, that marker for us was 5%. All right, I think I have another statement that comes after this as well. So let me check on that. Must be missing a sheet. 70, 71. All right, so let's go here. Everybody done with this before we leave it? So as far as the process, is everybody okay with the process? The main thing that we're emphasizing here is when you get your information from your problem, this is your mean. This is how you find your standard deviation. Then you take that and use this process to find your z-score. Once you go to your z-score, you hit the chart to get this value. All right, and that is actually it for 8.1. Yep, those are the type of problems that you'll see in this section, and that's the process. You get your value, once again, you get your values from your problem, recognizing that if it's normally distributed, sample distribution, it fits these criteria, which your population is, the population mean is going to be the mean of your sampling distribution. Standard deviation of your sampling distribution is found this way. Use those two pieces to find your z-score. Then use your z-score to go to the chart and then get your chart value. So before we see if we can help out Ms. Buffalo with a few of her questions, is everybody all right with 8.1? All right. Ms. Buffalo, you said you wanted me to check on some z-score work for you. All right. Ms. Buffalo, did you have those questions? Can y'all hear me? Because I don't see anybody, so I don't know if anybody's frozen or not.
I hear you.
Okay, cool. Did anybody have any questions?
Mm-hmm. I do. Homework 7.2, but question 2.
All right, so let me go there.
Didn't want to mess with Miss Buffalo.
Yeah, she may have had to step away. But normally she would have responded. All right, so preview. Is this one right here, sir? Determine the area under the normal curve.
Yes, sir.
Yeah, that's the one getting me too.
Okay, cool. We all in the same spot. All right, cool. So let me see what they give you as far as click here to table. Okay, so they give you the Z-score chart right here, so you don't have to go flip into it.
Yeah, that's the one I've printed out 900 times.
All
Doesn't
right,
work.
so let me see. They give us between -4.6 and 4.6. So, oh, didn't mean to do that.
I think I was able to solve. Remember I told you I had some of them I actually was able to solve.
Mm-hmm.
I think there's one that I found a calculator where you can actually put it in as the between,
Mm-hmm.
and it gave me the right answer.
Yeah, they got all types of stuff out there.
Oh please, half of them don't work. Oh, I think this one because it specifically said above, below, and then between.
Mm-hmm.
And when I entered the numbers into the between area,
Mm-hmm.
it calculated it right.
Okay.
Don't pay me no man, I don't know.
Got trying to see if I got both of my charts. Okay, and that's negative. All right, so just showing you guys what I'm doing. So the first was -4.6. So we have -0.46. So we got -0.4 down here and 6 right here. So we just see where they meet. And it's at 0.3228. All right. And the next one, go to the positive Z-score side. And it's +4.6. And that's going to be 6.772.
And do you add those two together or subtract them?
Subtract. Whenever you want to do between, you're going to
Right.
subtract them. Mm-hmm. Mm-mm-mm-mm-mm. So we should get 0.3544. All right, so that's good to
Is
go.
correct.
Say again?
That is correct. That's what I got. My calculator actually worked today.
All right, sounds good, sounds good. Next one, we want between -1.21 and 0. So don't forget, that is, if it's 0, that means it's 0.00. All right, so I pulled the positive first, so that's all good. So 0.00 is right here. So it's
Is that
just at 0.5.
0.1151?
You talking for 0.00?
Uh-huh.
No, it should just be 0.5.
Where you get that from? See, that's what I'm talking about.
Right here, I got 0 and I got 0. So they're gonna
Oh,
meet up right here at the 0.5.
my Z-score don't look like that.
You got this chart?
It came out the book. That's all I could tell you.
Now you looking at the negative or the positive side?
Wait a minute, let me ask you a question. So for each problem that has a Z-score chart, are the Z-score charts different on each problem, the way they set up?
No, the Z-score, you should be looking at the same chart each time.
No, because mine on table 5, mine has negative 3.4 as the very first one.
Yeah, that's what I'm saying. So that's why I asked you, were you looking at the negative chart or the positive side, the positive chart? It's because the chart is two different sides.
This
You
is
got the
what
negative side and then you got the positive side.
I understand that, but this is what I print from the book. This is the way it printed out.
Right. So
And
now, so
hold
I can
on,
show you both sides are in the book. So
hold
it just
on.
depends on what you're looking at. So
I'll show you, man.
hold on. Let me stop sharing so I can see.
This is exactly how it came out the book when I printed it.
Yeah. So now go down to the bottom and look at 0.
Right, but I'm just saying my negative 3.4 is at the top for me.
Right.
There's
Right.
nothing.
I was about to show you mine. I was about to show you that as well. So I'm going to show you the difference between two, because now, does it have the positive values at the bottom of it?
Yeah.
Okay. See, the one the picture that I have they cut it in halves. So they put the negative on one side, and then on the next page is the positive.
And when you print it out, it just comes out as one.
Right.
Gotcha. That's what's been messing me up, I bet you.
It probably is.
Oh, man.
But you still, when you go to 0, 0, it still should be at 0.5 for you.
Let me see.
Mm-hmm.
Because I think that's what's been throwing me. Negative 0 or, yep, 0.
Either one of them should be fine.
Yep. Okay, I see what you said. Okay.
All right, cool. So let me go here and put that in the notes. So it's 0.5 and negative 1.21 is the next one. So so we're looking at negative 1.21, so negative 1.2, and then 1 is right here.
I got 0.1131 for.
Yep. You got it, man.
Uh-oh.
So 0.1131. Sorry, y'all. My daughter started terrorizing. All right. So we got 0.5 minus the 1131. And that should be 0.3869. All right. Questions on?
Nope.
All right. And so the last one was doing the same thing. So, all right. What other questions we have out of 7.2? Or are we good to go with that?
Good.
Sounds good, sir.
Thank you.
We on the test.
What was that again, ma'am?
Can you not put it on the final exam?
We'll think, but I haven't made it yet. So I'll keep you in mind when I make it.
Help me, Jesus.
So anything else before we close out today?
No, I'm going to get my wig fixed, so I'll be prepared for my final exam.
All right, ain't nothing wrong with that. So with that being said, you guys have a good one. Next class, we'll get into 8.2. And, as far as chapter 8 is concerned, there are only 2 sections, 8.1 and 8.2. And then we'll talk about how we're going to move forward.
All right. Have a good day. See you Thursday.
All right. You have a good one too. Take care.